This is Geometry Chapter 12, Lesson 4. This is Inscribed Angles. So we have talked thus far about central angles. And a central angle, how is it related to its intercepted arc?
Equal.
They're equal. All right. Now, where does the vertex of a central angle lie?
In the midpoint.
At the center of the circle, right? All right. Now, we're going to have inscribed angles. An inscribed angle is merely an angle whose vertex lies on the circle. Okay? The center is not where the vertex is. This is called inscribed. Anytime you have anything that is inside a circle, like that trapezoid in that proof, the trapezoid in the proof, which I should not have erased because we're going to go back and look at this one. This is A, B, C, D. All right. We knew that those arcs were equal. We're going to go back and look at this. All right. All of these angles are inscribed. In fact, the entire trapezoid is inscribed in the circle because its vertices all lie on the circle. All right, whereas the central angle equals the measure of its intercepted arc. When the angle is inscribed, this angle equals 1/2 of the intercepted arc. All right, so we'll label this like that. So we know that angle AOB is going to be 1/2 the measure of arc AB. Inscribed angles are always equal to 1/2 the measure of its inscribed angle. We could also say, if I have the measure of AB, then I can know that the angle AOB, and if I am given angle AOB, that twice the measure of any angle, inscribed angle equals the measure of the arc. Got it? Makes sense? The angle is 1/2 the arc. The arc is twice the angle. Got it? All right, so let's look at your theorems. An inscribed angle is equal in measure to 1/2 its intercepted arc. Inscribed angles that intercept the same arc are equal. Let's look at that. Inscribed angles that intercept the same arc are equal. All right, so let's look at a picture. That's what this looks like. All right. So if I label that A, B, C, D, I want us to look very carefully at which of these angles are equal. All right. What arc does AB intercept? Does angle A intercept? Sorry. Angle A intercepts what arc? B, C. Do you see that? Got it? Do you see it? All right. What does angle B? What's the arc it intercepts? AD. Do you see that?
Oh.
Okay. All right. What does angle C? What arc does it intercept?
AB. Or D.
AD. What does angle D intercept? What arc?
BC.
So what angles have to be equal?
Angle A.
A and D have to equal arc B and C. Arc BC equals arc BC. That's kind of obvious. And angle B has to equal C. All right. Now, let's go back here. And let's look at this in terms of arcs. Okay? What does angle B intercept? One, it's going to equal half, right? The measure of what? Would I write it as AC?
ADC, because it's a major.
I would write it ADC because it's a major arc. Can I divide that into two arcs? What is the sum of what two arcs? AD plus DC, right? Do I have any two arcs that are equal? What arcs are equal? AB equals DC. All right, I'm going to erase this so we can keep working, and because I want you to think outside the box, right? All right, so we have angle B is 1/2 the measure, the sum of those two arcs, right? All right, let's look at angle C. What does angle C equal? 1/2 BAD. The measure of BAD. Can we break that up? Measure of BA. Measure of AD. I'm going to say AD. Yeah. Okay, look at this. Everybody look. Everyone look. Both of these equal half the sum of that. Can I change one of the other ones? Maybe this one or this one. So angle C is 1/2 the measure of DC plus the measure of AD. Why can I do that? It's called substitution.
Wait, what?
Because I said AB equals DC. So for AB, I substituted in DC. Are you following me? Can I say angle B equals angle C?
Yes.
Why? No. Substitution.
No, because it just
Not based on what I've said.
Okay.
That's right. I had them both equaling the same arc. Well, okay, this would be the arc addition postulate, right? This one would be the arc addition postulate. This would be inscribed angle equals half the measure of its intercepted arc. So think of the reasons, all right? So you could have seen that proof by looking at the arcs and the inscribed angles and using substitution. All right. Now, let's go to the next one. So I want you to really think about this. If I have a circle, my circles are getting poorer and poorer. All right, are my angles inscribed?
Yes.
They are, yes. I want you to look particularly at angle B. Could you tell me the measure of angle B?
180 divided by 2.
Correct. AC is 180 degrees, so angle B has to be, do you know why? Because every angle inscribed in a semicircle is a right angle because the arc it intercepts is 180 degrees. I oftentimes see this concept on the ACT. All right? So when an angle is inscribed in a semicircle, it is, in fact, a 90-degree angle. Okay, so we're going to work some practice problems. All right.
Your footballs are just getting better and better.
Thank you. I feel like they're getting worse and worse. I want you to think about that.
That one wasn't so great.
Thank you. Like, really, thank you. Not.
Is the right one 30 degrees?
That is 35. This is 35 degrees. Sorry. 35 degrees. That's 5x minus 1. All right, let's work these. They go from easy to hard. All right. I should have marked them. This one, okay. Jaden, what's the measure of that angle?
Is it 40 degrees?
It's 40 degrees. That is correct, 40 degrees. All right. I could make this one a little harder too.
I don't understand that one.
This one?
No,
This
that
one? Okay. That's okay. I'm about to make it harder. Okay, that's 35 degrees, y'all. I'm just making up something here. Okay, we're going to say that is that. So we're going to figure that one out too.
105?
Huh?
Is that 105?
That's 105. That's 35.
I see. 105.
Okay, we want that angle.
210.
Jake, do you know that angle? This one. What? 40?
Yeah, sure.
You're just guessing?
Wait, how did you do it?
It's not 40. That's not correct.
I know.
Okay,
I don't even know where to start. Are we looking at the angle or the arc?
we're looking at this angle, then we're going to come to the arc.
Maybe.
What? What, Jaden?
Well, I don't know how to get the answer, but do you start by saying that it's a vertical angle, so 100 is, the other side's also 100 of the,
No.
or do you add the sum of the other sides?
What arc does 35 degrees intercept?
That one there.
Oh my days.
That one.
Oh my days.
You see it?
Yes, ma'am.
Damn.
So what is it, Evie? What is this angle?
So they're equal?
It has to be 35 as well because it also intercepts that same arc. Right? All right. Trez, what's that?
I said 150.
Is this 150?
Yeah.
How'd you get 150?
I just forgot that I added
I 105 plus 105 is 210. Subtract 360 subtract that from 360 and you get 1.
Okay, there's an easier way.
Okay, do that.
What is it, Finley?
It's 180 minus 105 since they're
180 minus 105 minus 35 gives me,
well, what I did, I just did 180 minus 105, and then you have that angle, and you multiply it by 2.
okay, that might not be right. What's 180 minus 105 and 135? Yep, 150 isn't right.
What?
The sum of the angles in a triangle is
180.
180. These three angles have to equal 180. What's 180? This has got to be 40. Because 40 and 105 and 35 is 180. So what's this arc? No, not 40. It's 80 twice.
Oh, it's 40.
Because if that angle is 40, the arc it intercepts is that arc.
Double.
It's double. That's right.
Wait, so the angle from the middle doesn't work?
That is not a central angle. We do not know where the center is. So you can never assume that's the center.
I see.
The center could be over here.
I see.
Got it? Okay. What about,
Is that
which
3
one do we want to do? Huh?
Is that 3 degrees?
3 degrees. What do you mean?
Oh, is it
70, 49, and I have nothing.
I can't read, sorry.
No, it's my writing. 70 degrees, 49 degrees. What's the measure of that arc? Finley, what is it?
122.
How do you know?
I found the angle.
What's the angle?
70 plus 49. 61.
So it's 61.
Then multiply.
So that arc is going to be
61 times 2.
122, right? Okay, now guys, how are we going to do this one?
I don't know what it says. 5x.
This says 5x minus 1, and this says 8x plus 14. So how are we going to figure that out? What's an equation, Will? Go ahead, Hannah, tell me.
5x is that what's in
Minus 1.
times 2, like, yeah, equals 8x plus 14.
That's correct. That is correct.
Good job, kid.
Because the arc is twice the angle. Yes. See if you wouldn't sit in the back of the class.
Yeah, it does actually.
No, it doesn't.
Oh, actually, it
also
does.
not have-
Not really. It looks like it looks like some good like an H.
Yeah.
You also not multiply by 2 and divide the other side by 2.
8.
Yes, you could have multiplied this by 1/2. Yes.
Equals 8.
Equals 16. X equals.
Yes. And then x is 8.